Good afternoon to all. In the last class, we discussed the classification of colloids on the basis of dispersed phase and dispersion medium. In this class, again, we can classify the colloids on the basis of classification of colloids. Classification of colloids. In the second classification, on the basis of interaction, on the basis of interaction between dispersed phase and dispersion medium. Dispersed phase and dispersion medium. On the basis of interaction between dispersed phase and dispersion medium, we can classify colloids into two categories. The first one is lyophilic colloids. Lyophilic salts. And second one is lyophobic salts. Lyophilic salts. If we take it as solvent, as means water solvent, then it is water loving, means solvent attracting. It is lyophobic, means solvent repelling. Okay, lyophilic means solvent attracting, lyophobic means solvent repelling. If the solvent is water, then it is water loving. Lyophilic salt is water loving. If the solvent is water, in the case of lyophobic, is water hating. Okay, this is the classification on the basis of the interaction between dispersed phase and dispersion medium. Before discussing this lyophilic and lyophobic salts, what is mean by dispersed phase and dispersion medium? Okay, dispersed phase is nothing but it is the discontinuous phase of colloidal particles in colloidal system. Means it is a discontinuous, not continuous. The discontinuous phase of colloidal particles in colloidal system is called as dispersed phase. And next one is dispersion medium. What is mean by dispersion medium? Dispersion medium is nothing but the continuous medium in which the the particles of dispersed phase are dispersed. That medium we can call as dispersion medium. Means the continuous medium in which the colloidal particles, that is the dispersed phase particles, are dispersed. In that medium we can call it as dispersion medium. This is the definitions of dispersed phase and dispersion medium. Now we move on to what is meant by lyophilic salts and lyophobic salts. First one, lyophilic salts. Lyophilic salts. Lyophilic salts are defined as the colloidal particles, means the particles of the colloidal particles, the colloids. In colloids, the particles of in colloids, In colloids, the particles of dispersed phase, dispersed phase, dispersed phase, dispersed phase has much affinity, has much affinity, has much affinity for dispersion medium, for the dispersion medium, for the dispersion medium. Are called as lyophilic salts. Means in colloids, the particles of dispersed phase has much affinity for dispersion medium. Example for this one is starch salt, proteins. These are the best example for lyophilic salts or water loving salts. And next we move on to lyophobic salts. Lyophobic salts. Lyophobic salts. What is meant by lyophobic salts? In colloids means the particle size in between 1 nanometer to 1000 nanometer. In colloids, the particles of dispersed phase has no much affinity, has no much affinity for dispersion medium, has no much affinity for dispersion medium. Are called as lyophobic salts or water hating salts. Okay. Example for this one is aluminum hydroxide in water. So aluminum hydroxide. Aluminum hydroxide in water are called as lyophobic salts. Okay. These are the definitions of lyophilic salt and lyophobic salts. Affinity means similarity. If the colloidal particles are similar, the particles of dispersed phase and dispersion medium are nothing but lyophilic salts. If in a colloidal solutions the particles of dispersed phase has no much affinity, has no much similarity for the dispersion medium are called as lyophobic salts. Example for this one is aluminum hydroxide in water solution. In water. Next we move on to differences between lyophilic salts and lyophobic salts. Differences between lyophilic and lyophobic salts. The first column is lyophilic salt. Lyophilic salts. Next column is lyophobic salts. Lyophobic salts. These are the differences are important for the exam point of view. Okay, they may ask for 3 marks questions. Write the differences between lyophilic salts and lyophobic salts. The first one is you can write definition. You write first one is definition. In colloids, In colloids, the particles of dispersed phase, the particles of dispersed phase has much affinity, has much affinity for dispersion medium. The first difference. In this case, again you write the definition of lyophobic soils. Okay, in colloids, the particles of dispersed phase has no much affinity, for dispersion medium. This is the first difference. Next, second one is lyophilic soils are stable. The soils are very stable in nature. The soils are very stable in nature, very stable. The second difference. In the case of lyophobic, these are stable only in presence of protective agents. These soils are stable only in presence of protective agents. In this side, the third one is lyophilic soils are reversible in nature. Whereas lyophobic soils are irreversible. Next, fourth one is they cannot be easily precipitated. They cannot be easily precipitated or coagulated in presence of an electrolyte. That means coagulated by adding an electrolyte. Means by adding electrolyte, they cannot be easily precipitated or coagulated. You already know the meaning of precipitated in means in lab practicals. You know precipitation. You got the test while doing the practical test. You know the meaning of precipitation. Okay. Now in this case, they can easily precipitated are coagulated by adding an electrolyte. Next, the last difference is they can prepare, they can prepare, they can be prepared direct mixing of by direct mixing of dispersed phase and dispersion medium. In this case, they need special methods for the preparation of lyophobic salts. They need special methods. They need special methods for preparation. You also write the example for lyophilic salt and lyophobic salts. Example for lyophilic salt is starch or proteins. Starch or proteins. In this case, lyophobic salts, what happens? Aluminum hydroxide in water. Example, these are the 5 differences between lyophilic and lyophobic salts. The first one is the definition you write the first definition you write both sides, and the next one is the salts are very stable in nature. Lyophilic salts are stable in nature. They are stable only in presence of protective agents. And third one is they are reversible in nature. They are irreversible in nature. They cannot be precipitated or coagulated by adding an electrolyte. They can be precipitated or coagulated by adding an electrolyte. And the last one is they can be prepared by directly mixing of dispersed phase and dispersion medium. They need some special methods. These are the 5 differences between lyophilic salts and lyophobic salts. Next we discuss the classification of colloids on the basis of the number of types of particles present in dispersed phase. Classification of colloids on the basis of third category. On the basis of number of type of particles present in dispersed phase. Again, they are classified as 2 types. The first one is multi-molecular colloids. And second is macromolecular colloids. And third one is associative colloids. We will discuss one by one. First one is multimolecular colloids. Multimolecular colloids. What is meant by multimolecular colloids? In colloids, the large number of small particles the large number of Small particles, small particles means dispersed phase particles. Dispersed phase particles precipitated or coagulated. Precipitated precipitated and forms and forms the particles size having range of colloids are called as multimolecular colloids. Means small size particles are precipitate means dispersed phase particles. Means dispersed phase means the discontinuous phase of colloidal particles in colloidal system. The small size or large number of small particles are precipitated or coagulated. They forms the particles. Again, they form particles having the size of the range of the colloids. Means 1 nanometer to 1000 nanometer are called as multimolecular colloids. Example for this one is metal soles. Next, second is macromolecular colloids. Macromolecular colloids. What is mean by macromolecular colloids? The substances of particles in a substance large means large size particles are dispersed in dispersion medium are dispersed in dispersion medium and forms particles means colloidal particles and forms particles of size in colloidal range are called as macromolecular colloids. Means the large size particles are dispersed in a dispersion medium and forms the particles which having the size of colloids means 1 nanometer to 1000 nanometer. Those called as macromolecular colloids. Example for this one is starch solar proteins. Starch soles and proteins.